So today we are going to study about the reactions of carbonyl compound. So it is one of the important chapter of class 12th carbonyl compound, and in which we will cover the two major named reaction, that will be the aldol reaction and Cannizzaro reaction. So we all know about the carbonyl compound, like the ideal carbonyl compound looks like this. Here we have an sp2 carbon center, and here we can have, if we have hydrogen then it will be aldehyde, if we have another R group then it will be ketone, and so on, like ester and acid. We will cover today the two main reaction. If we take an example to understand, if we have a carbonyl compound like this, so any carbon which is attached to the carbonyl carbon, that is carbonyl is a functional group, so any carbon which is attached to the carbonyl carbon will be the alpha carbon, and the hydrogen attached to it is called alpha hydrogen. So let me show it like this. So this is the alpha hydrogen. Okay. So when we treat with NaOH, then if the carbonyl compound has alpha hydrogen, then in the presence of diluted NaOH it will show aldol reaction. We will see in detail how this reaction happens. And if our carbonyl compound does not contain any alpha hydrogen, like we have the benzaldehyde, the pH represents the benzene and this is the aldehyde group, so this is called the benzaldehyde. Okay. So here there is no carbon attached to the carbonyl carbon which has hydrogen. Okay. Like benzene if I draw, then you can see how it looks. Here there is no hydrogen at the alpha carbon, this is the alpha carbon, so there is no hydrogen at alpha carbon, so there is no alpha hydrogen. Here also the hydrogen is directly attached to the carbonyl, so there is no alpha hydrogen. So in this type of carbonyl compound where there is no alpha hydrogen, and if we treat with concentrated NaOH, like concentrated NaOH, usually we take 40% of NaOH or greater, 50% of NaOH can also do the reaction, but minimum 40% of NaOH we take to have reaction, and after this it will undergo Cannizzaro reaction. Okay. So what are the products it form? It depends, and we will see one by one. Okay. So let me start first reaction, that is the aldol reaction. Basically the aldol is known as the Aldol condensation reaction, because ultimately in the reaction the water molecules will be released. Okay. So let me take an example. So I am taking PH C double bond O CH3. Okay. So this is called the acetophenone. Okay. So this is the acetophenone, and when we treat it with an diluted NaOH, what will happen? It has the alpha carbon, and alpha carbon has alpha hydrogen. So this NaOH will have Na plus and OH minus. That OH minus have two roles. The one, it can act as a base, and another it can act as a nucleophile. It can act as both. Okay. So here you can see, if it act as a nucleophile, it will first try to attack. It is a nucleophile, that means it will attack to electrophilic center. What is the electrophilic center? Where there is a delta positive charge. Okay. So since oxygen is electronegative than carbon, here will be del negative, here will be del positive. So that OH minus will try to attack this carbonyl center, which is electrophilic in nature. Okay. So it will form O minus, and here we will have OH, and that CH3 I am drawing here. Okay. And then when this will form, there will be no such product. Okay. Because in one carbon two electronegative elements cannot stay simultaneously. So what will happen? This negative charge will again come back, and that OH will again leaves as an OH minus. So this will be the reversible reaction. Okay. Then what will happen? We try to act OH as a nucleophile, but no product is forming, because at one carbon center two electronegative atom cannot exist simultaneously. Let us act OH like a base. Okay. So we have acetophenone and we have alpha hydrogen over here. So when OH minus act as a base, it will abstract the acidic proton. Okay. So why this hydrogen will be acidic? It is because at the alpha position of this carbon, okay, there is a carbonyl which is a electron withdrawing group. Okay. So when this OH minus will take this proton, what will happen? Its negative charge will be delocalized over the carbonyl. Okay. So what will form? It will form a compound like this. Okay. So this is called the enol form. Okay, this is called enol form, and this was the keto form. Okay. So this enol form is very reactive. This enol form is very reactive. So again, what it can do, when it will come back, okay, that negative charge will localize on the carbon. So what it will do, it will attack on another molecule, like the same molecule of that acetophenone. Okay. So this carbon will attack to this carbonyl carbon, and what will form? It will form a complex like this. Okay. So it will be CH2, and then it will go here, here it will be, when it will attack, this pi bond will break towards the oxygen because it is electronegative. Okay. So we will having CH3 over here and pH over here. Now what will happen, since we have taken diluted NaOH, it in aqueous solution, okay, it means in water. So in solution we have water. So what will happen, this O minus will take proton from the solution. Okay. So it will take proton, and what it will form? It will form the compound like this. Okay. So here we have the ketone and the alcohol group in the same compound, and this is called the aldol. This is called the aldol. Okay. So this compound is called the aldol. Now what will happen? Let me rub the upper side. Okay. So now we have the aldol. Okay. So I am writing it above. So we have aldol. Here we have CH3 and here we have pH. Okay. So now in the solution OH minus is present in excess, so we can write it OH minus, and again it can abstract proton. From where it will abstract? From the alpha position, because the alpha hydrogen are acidic hydrogen, because it can quickly form enol. So when it attack over here, what will happen? The negative charge will be delocalized in the carbonyl. Okay. Or we can simply write, if we do not want to delocalize, then we can simply write here negative charge. Okay. Right, OH, CH3 and pH. Okay. And then when this negative charge will come here, that OH will evolve as an OH minus. Okay, that will evolve as an OH minus, and since in the solutions we have the water. Okay, so we have water. So what will happen? That OH minus will simultaneously take the proton from the solution, and it will evolve like a H2O. It will evolve like an H2O. Then what will form? It will form alpha beta unsaturated carbonyl compound. It will form what is called, this is the alpha position and this is the beta position. So we have alpha beta unsaturated means double bond. Okay, that is pi bond. So it will be, the name of the compound product will be, this is our product, this is the product. So its name will be the alpha beta unsaturated carbonyl compound. Okay, carbonyl compound. Now what we call, when there is an elimination of water, we call it as a condensation reaction. Okay, so this compound is aldol, and since after the reaction when the OH minus take this proton, it forms an alpha beta unsaturated carbonyl compound, and since the elimination of water is occurring, so we will call it as an aldol condensation reaction. Okay, it will be called aldol condensation reaction. And since the elimination is occurring via formation of a negative charge, so this elimination reaction is called E1CB elimination reaction. Okay, so it is called E1CB elimination reaction. What is full form of E1CB? E1CB is the first order conjugate base elimination reactions. That means the elimination of this reaction will solely depend on this molecule concentration, and the elimination will proceed via an carbanion intermediate. The carbanion intermediate will ultimately lead to the elimination of a water molecules. So this is the typical reaction of a aldol condensation reaction. Okay, so we can have a question. So that question I am taking is slightly different, because in the example we will consider the intramolecular aldol condensation. Okay, and it is one of the previous year of JEE main exam. Okay, so JEE main 2025 April attempt, this question has come. Okay, so what is the question? The question is very easy. We have this. Okay, so we have 1, 2, 3, 4. Okay, so we have this compound. Okay, so in the same compound we have the two carbonyl functional group. One is the ketone and another is the aldehyde. Okay, so when we react it with diluted NaOH, what will happen? The aldol condensation will occur, because this carbonyl compound has alpha hydrogen over here. This is alpha carbon. Here we have alpha hydrogen also. Here it is also alpha carbon, and here the alpha hydrogen is also. In this aldehydic part we have alpha carbon where there is alpha hydrogen also. So from where the hydrogen will be extracted by the OH minus, diluted NaOH. So we have OH minus. Okay, so first we have to look like from where we have to abstract the OH minus. Okay, so the rule is, I want to write some rules for this. So let me write some rules. First is that in the intramolecular aldol condensation, the product is a cyclic compound. So first we have to first we have to check the number of ring, like how many member ring it is forming. So we have to go first with a 6 member ring, then we will go with 5 member ring, and then we will go with the 4 member ring, 7 member ring. Okay, and then next we consider from where the alpha hydrogen has to be gone. So the more substituted enol should form, enol should form. Okay, and the attack will be to and attacking to less hinder more electrophilic carbonyl. Okay, more electrophilic carbonyl. So we have to check first how we can make a 6 member ring. Okay, so we can directly do this by having a trick. Okay, so what is the trick? So let me first explain, then we will come back to this question. So we have taken the example of acetophenone. Okay, so first you have to draw acetophenone, and then you have to draw alpha hydrogen separately. Okay, you have to draw alpha hydrogen separately, and then draw the carbonyl compound below to the alpha hydrogen. So how you can draw the carbonyl compound below alpha hydrogen? You can simply write same molecule over here, Okay. So the trick is you have to remove the 2 hydrogen from the, this is the trick, I have already shown the mechanism. So trick is you have to draw 2 hydrogen from the alpha carbon and the oxygen of the carbonyl compound of another molecule. Okay. So just remove this as a water in the presence of diluted NaOH, and then the product will form. Okay. So it will form. So it will form the same product, that is the alpha beta unsaturated carbonyl compound. Unsaturated carbonyl compound. Okay. So this is the trick. We can simply remove the 2 hydrogen from the alpha carbon of one carbonyl and then the oxygen of another carbonyl, and we can simply form the product, aldol condensation product. Okay. So here we will also apply the same trick. Okay. Here we will also apply the same trick. So first we have to check how many member of ring it is forming. Okay. So one, if we are making the enol from this carbon, then it will attack to this carbonyl. Okay. So how many member of ring it will form? 1, 2, 3, 4, 5, 6, 7, and it is in the priority last. Okay. So here the proton will be not extracted. Okay. So from here I am removing. If we making the enol from this alpha carbon, then what will happen? Then we can count 1, 2, 3, 4 and 5. Okay, this is also good. And then another option is that we can make the enol from this carbon. Okay, so from where we can have the enol, and then when it will attack to this carbonyl, it will be 1, 2, 3, 4, 5. So it is forming 5 member ring from both sides, from here also and from here also. Then we will look to the second rule, which is that more substituted enol will form and it will attack to the less hindered more electrophilic carbonyl. Okay. Since we have one aldehyde and one ketone, so we know the aldehyde is more electrophilic. Why? Because in ketone there is a plus I effect, plus inductive effect from both the end. So there will be less positive charge in ketone, while in aldehyde we will have more positive charge at that carbonyl, because the inductive will be only from one side. Hydrogen will not have that significant inductive. Okay. So we have our answer. Let me remove all these things. The enol at here we will having 7 member ring, and by forming enol at this we have the 5 member ring. So 5 member ring will prepare. So this is our first carbon atom, this is second, this is third, this is fourth, this is our fifth carbon atom. Okay. And then this is the alpha carbon position, we have alpha hydrogen, and then removing the water molecule and the product will be ready. This will be our product, that is the alpha beta unsaturated carbonyl compound. Carbonyl compound. Okay. So thank you very much. कितना मिनट हो गया?